We will discuss about union and OR operator in this video. We will basically check for this particular scenario whether union or the OR operator is going to perform well. You need to understand is like we will not be able to use something blindly, like stating like whether union is going to be the best fit or OR is going to be the best fit. That's the reason I'm telling like for this scenario, we are going to check whether union or the OR operator is going to perform well as far as the query is concerned. I'm going to use AdventureWorks DW database for this demo. I'm going to create a table called table1 underscore temp, and this table will be populated with 10,000 records from table 1. And then I'll be creating a primary key constraint on column 1 as far as table1 underscore temp table is concerned. I'm going to create another table called table2 underscore temp. Likewise, I'm going to insert close to 10,000 rows onto table 2 underscore temp, and these 10,000 rows will be coming from a table called table 1. And then I'll be basically creating an primary key constraint on column 1 for table 2 underscore temp. Now, what I'm going to do is like I'm going to turn on statistics time and IO, and I'm going to execute this query, which basically contains a distinct operator. So what I'm going to do is like I'm going to select distinct column 2 and column 3 as far as table 2 underscore temp is concerned, and I'll be doing an inner join between table 1 and table 1 underscore temp and table 2 underscore temp. And I'll be using a join condition of table 1 underscore temp column 1 and table 2 underscore temp column 1, and then use a OR clause, and then going to compare column 4 between each of these two tables. So basically like it is the join condition has a OR condition. So let's execute this query with the actual execution plan. So let's wait for this query to complete. And once this query completes, what we'll do is like we will look at the execution plan and then see the estimates and also like see which particular operator is costly, and also look at the statistics profile too. So let's first look at the execution plan. So what I'm seeing is like I'm able to see a cluster index scan happening on table 2 underscore temp and table 1 underscore temp. And if I look at the cluster index scan on table 2 underscore temp, I'm estimating close to 10,000 records, and I'm returning 10,000 records. And as far as table 1 underscore temp, where I'm doing a cluster index scan, I'm estimating close to 10,000 records, and the actual number of rows read is close to 80,000 records. And now I have a table spool operator. So we basically get a table spool. For example, if the optimizer thinks like a temporary calculation has to be made, so we basically use the table spool for that. And now if I look at the table spool, what I'm seeing is like the estimated number of rows is like 100 million. That's what I'm seeing here. It is estimating 100 million, and what I'm seeing is like the actual number of rows read is close to 99 million, and actual number of rows for all execution is also like close to 100 million. We know that the table has got close to 10,000 records, but the calculation that is happening as far as the table spool is concerned, we are able to see that it is close to 100 million. And then we have a nested loop, and then we have a parallelism operator. And what I'm seeing is like there is a sort operation happening, which has basically spilled to TempDB. And this is what I'm seeing as far as the OR is concerned. Now, looking at the statistics profile, what I'm saying is like since we have an spilled sort operation, we have a work table which basically performs close to 531,000, close to 531,000 logical reads. Everything else seems to be little okay. Like for table 1 underscore temp, I'm doing 408 logical reads, and for table 2 underscore temp, I'm doing close to 148 logical reads. But the logical reads as far as work table is concerned, that is a little high. And now what I'm seeing is like this query is taking close to 14 seconds to complete. and I'm using like 69 seconds of CPU. So what I'm going to do is like if I look at the execution plan again, this table spool seems to be like at least like what I'm feeling is like even though it is going to do this temporary operation, the amount of operation that this one is doing, which is close to 100 million, seems to be very, very high. So what I want to do, I want to remove this table spool. And I also know like when you have a table spool on the inner side of a nested loop, it causes a performance issue. So let me show you an article that was written by Jack Lee where he speaks about this. So if you look at it, it basically is same scenario as where you have a table spool operator on the inner side of the nested loop. So if you look at this information more, you get this details. The spool operator helps improve a query performance because it stores intermediate results so that SQL doesn't have to rescan or recompute for repeated use. Spool operator has many usage, okay? And this is the important thing that I want to update here, which is spool improves performance in majority of the cases, but it's based on the estimates. Sometimes this can be incorrect due to unevenly distributed or skewed data causing slow performance. So this can sometimes cause bad performance. And there is a way to, you can actually disable the spool on the inner side of the nested loop. We have a spool on the inner side of the nested loop with trace flag 8690. So what I'm going to do, I will follow this article and then I will enable trace flag 8690 just for this query. So what I'll do is like I will go ahead and add this option query trace on 8690 and then execute this query one more time. So let's wait for this query to complete. Let's see, hoping that this should resolve the issue. Previously, it was taking close to 14 seconds. Now let's see if 8690 trace flag is going to remove the spool operator. So the performance has improved to an extent. Like previously, we spent close to 14 seconds, but now we are spending just 12 seconds. We were able to save close to 2 seconds. And what I remember is like we were performing close to 67 seconds of CPU, but now we are just doing 56. Like we were able to save like 12 seconds of CPU. Now looking at the execution plan, what I'm able to see is like I've removed the spool operator when I use this 8690. But when I look at this estimate here, what I'm seeing is that now this cluster index scan is basically estimating close to 100 million, and then the number of rows read is 100 million, and then I'm returning that much rows. And if you see here specifically, this is same. This seems to be the one where estimated number of rows per execution is 10,000, and the estimated number of rows for all execution is like 100 million. So basically what we are doing is like for each iteration we are reading 10,000 rows, and it seems like kind of an multiplication of rows where for each of the every row from the top we are doing a full scan on the bottom. So that is what is happening, and even in this case we are basically spilling to the temp-db. Sort operation is spilling to the temp-db, and if I look at the statistics profile, what I'm seeing is like table 2 underscore temp is doing close to 510,000. This query is definitely improved when compared to the previous query, but I'm not sure if this is the best performance that we can achieve. So what I'm going to do now is like I'm going to replace this OR operator using a union. So what I'm doing here is like I'm basically using a select distinct b dot column 2 and b dot column 3, basically like I'm getting it from table 2 underscore temp, column 2 and column 3, and joining table 1 temp and table 2 underscore temp, and the join condition is column 1 equal to table 2 underscore temp column 1, and then I'm unioning it with the same query. The only difference is like the join condition is column 4 equal to column 4. So I will execute this query now. if I execute this query, the query completes right away. It is not taking 14 seconds or 12 seconds, but it is taking some milliseconds. Now, I look at the execution plan. The execution plan seems to be little wide. It is not sleek as last time, but what is happening is like I'm not using a I'm not using a merge join or nested loop. I'm using a merge join for the first query, and then another one I'm basically using an hash match, and whatever results we are getting, we are joining using the merge join. So what I'm basically doing, I'm reading across each of these table twice. Previously, what we were doing is like we basically read the information on these tables once, but in this case, we are reading the data from each of these tables twice. So there is the first query is this one, and the second query is this one, and the union is basically happening here. So if you look at it here, the union is basically happening using the physical operation merge join. And looking at the statistics profile, like I'm able to reduce the logical reads completely. Like 510,000 previously has come down to zero, and the logical reads maximum is 102. And if you look at it, the query previously used to take 14 seconds or 12 seconds is now just taking 90 milliseconds, and CPU time is like insanely less, wherein previously I was taking 67 seconds. Now it has come down to 15 milliseconds. Now what I'll do is like I will execute all these three queries side by side, and then let's compare the results once we complete the execution. So it's going to take at least like more than 30 seconds, I guess, but we will be able to look at all these queries, execution plan and statistics profile side by side, and that's going to give us very good information. So just a recap, we started with an OR operator, and then we saw a spool operator on that, and then we basically used in trace flag 8690, and then we completely rewrote the query and replaced the OR operator using union operator. So now looking at the execution plan for each of these queries, what I'm seeing is like the first query is basically showing as the cost is 40%, the second query is 59%, and third query is 0%. At least looking at this, what I'm understanding is like the second query is costlier, first query is comparably comes next, and then the third query seems to be very less costly. And if I look at it, the first query basically has a cost of around 193, and second query has a cost of close to 285, and the third query is basically having a cost of 1.6. And this is where we were able to calculate this query cost relative to the batch from the subtree cost. Now looking at the number of data that we are dealing with, what we are able to see is like the first query and second query is dealing with close to 100 million records. But as far as the third query is concerned, even though it is little wide, what I'm seeing is like we are not dealing data more than 10,000. It is specifically dealing with whatever we have on that particular table. So that is what is happening here. And looking at the statistics profile, what I'm able to see is that the first query is performing close to 531,000 logical reads. The work table is performing that much, and this is because we have this table spool operator. The second query is performing close to 510,000 logical reads, and this is happening on table 2 underscore temp. But on the other hand, the third query, which uses the union operator, performs close to 102 plus 102 logical reads, which is close to 204. So simple rewrite is able to solve this performance issue completely, and this improvement that we are seeing, at least on the logical reads, is like several thousand times improvement. Like it is like close to 50,000 x improvement when we rewrote this query using union operator. So it's better we look at options and then try rewriting the query if that is possible. And also like there is no way we can confirm that union is always better than or. It all depends on the scenario. In this scenario, what I understand is like union is really good when compared to or operator. That's it for this video. Thanks for watching. Have a great day. Jai Hind.